Hello everyone, I want to remind you again that the science semester test is scheduled on the 20th of May 2020. I am hoping that everyone is ready for it. To help you in your preparation, I will inform you again of the lessons you need to review, so let's watch it. Try to shine a flashlight on a wall in a dark room. What can we see? Yes, we will see the light come out through the flashlight and form a beam of light on the wall. Then, we place an object or a material between a flashlight and wall. Example, an opaque material. What do we see now? We will see that the light is blocked by the object. The opaque material does not allow light to pass through it. The object blocks the light and a dark area is formed behind the material. This dark area is called a shadow. So a shadow is an area of darkness formed when the light is totally or partially blocked. Materials. Materials are substances or mixtures of substances that constitute an object. Materials can be pure or impure, living or non-living matter. Materials can be classified based on their physical and chemical properties, or on their geological origin or biological function. Do all materials allow light to pass through them? No. There are three types of materials. They are transparent materials, translucent materials, and opaque materials. Transparent materials are the materials which allow most of the light to pass through them. Example, clear plastic. Translucent materials are the materials which allow only some light to pass through them. Example, frosted glass. Opaque materials are the materials which do not allow any light to pass through them. Example, wooden door or wall. An eclipse occurs when one object in space blocks an observer from seeing another object in space. From Earth, eclipses occur when only the Sun, the Moon, and the Earth are on a straight line. There are two main types of eclipses, solar eclipse and lunar eclipse. First, a solar eclipse. A solar eclipse occurs when the moon passes in front of the sun, causing a shadow to fall on certain portions of the earth. The eclipse is not seen from every place on earth, but only from the locations where the shadow falls. From these locations, it appears as if the sun has gone dark. There are three main parts of the moon's shadow during an eclipse called the umbra, penumbra, and antumbra. Umbra. The umbra is the portion of the moon's shadow where the moon completely covers the sun. Antumbra. The area of the shadow beyond the point of the umbra. Here the moon is completely in front of the sun but doesn't cover the entire sun. The outline of the sun can be seen around the shadow of the moon. Penumbra. The area of the shadow where only a portion of the moon is in front of the sun. Depending on what part of the shadow you are located in, there are three types of eclipses. First, total. A total eclipse is where the sun is covered completely by the moon. The portion of the earth that is in the umbra experiences a total eclipse. Second, annular. An annular eclipse is when the moon covers the sun, but the sun can be seen around the edges of the moon. An annular eclipse occurs when the viewer is within the atumbra. Third, partial. A partial eclipse is when only a portion of the sun is blocked by the moon. It occurs when the observer is within the penumbra. Don't look at a solar eclipse. Even though it appears darker, the harmful rays of the sun can still damage your eyes. Second, a lunar eclipse. A lunar eclipse occurs when the moon passes through the Earth's shadow. Lunar eclipses have the same three phases or types as solar eclipses. Lunar eclipses can be seen by a much larger area of the Earth than solar eclipses. They also can be viewed without special equipment to protect the eyes. Lunar eclipses are not totally dark. The moon will reflect some sunlight that is refracted by the Earth's atmosphere. The light that is reflected is reddish in color and can cause the moon to appear a dark brownish red. The human eye is one of the most valuable sense organs that enables us to see the world around us. Now, let us study about different parts of an eye. As we can see the picture, there will be a retina, vitreous gel, iris, cornea, pupil, lens, optic nerve, and macula. The cornea is the clear outer part of the eye's focusing system located at the front of the eye. The iris is the colored part of the eye that regulates the amount of light entering the eye. The lens is a clear part of the eye behind the iris that helps to focus light or an image on the retina. The macula is the small sensitive area of the retina that gives central vision. It is located in the center of the retina. The optic nerve is the largest sensory nerve of the eye. It carries impulses for sight from the retina to the brain. The pupil is the opening at the center of the iris. The iris adjusts the size of the pupils and controls the amount of light that can enter the eye. The retina is the light-sensitive tissue at the back of the eye. The retina converts light into electrical impulses that are sent to the brain through the optic nerve. The vitreous gel is a transparent, colorless mass that fills the rear two-thirds of the eyeball between the lens and the retina.
The Earth and beyond. The Earth is one of the planets in our solar system. Earth is our home. It is the planet that we live on. Our Earth is a very special planet, which is why we can live on it. And not only us, animals, plants, and even bacteria can live on Earth. And beyond the Earth, we can find sun, moon, planets, meteor, asteroid, comets, and other space things. The lesson will concentrate on the Earth and beyond, specifically answering the questions. Why is the Earth spinning? Why do you think so? What if the Earth stops spinning? What do you think will happen? So at the end of this discussion, we will check if these learning objectives are attained. First, investigate through modeling that the sun's apparent movement is caused by the Earth spinning on its axis. There is time that we can see the sun, but there is also time that we cannot see the sun. The sun looks like it appears and is gone. And the people in the past even thought that the sun moved around the earth. Is that true what they were thinking? Why were they thinking that way? Is it because the sun really moves? No, because the sun seems to move because the earth is rotating or spinning. Second, explain the relation of the spinning of the earth to day and night. Third, apply the knowledge learned today in doing the assignment. The Earth spins on its axis. But what does this mean? Look at the following picture. Imagine an orange with a pencil stuck through it. If you hold the pencil in your fingers, you can spin the orange around. The pencil is the axis of the orange. The Earth does not really have a pencil through it, but it does spin around. We can imagine a big pencil through the middle of the Earth. We are on the Earth. Let us imagine we are at the point where you see the red X on the orange. The sun shines on the Earth, and so we at X see the sun. We call that daytime. But the Earth never stops spinning. So we at X move around into the shaded part of the Earth. Then we cannot see the sun any longer, and it is night time for us at X. The Earth spins right around in 24 hours, so it will take 24 hours for us to come around to the same position you see in the picture. We call 24 hours a day. When we say a day, we really mean a day and night. Together they last 24 hours. If we are at position X, we move past the sun, but to us, it looks as if the sun is moving. The sun seems to move from the east to the west. The sun seems to come up or rise in the east, move across the sky during the day and go down or set in the west. But the sun does not actually move. Let us check if we attain the learning objectives on this discussion. First, We already know now that the sun seems to move but actually not. The Earth that spins on its axis and makes the sun look moving. The Earth also will take 24 hours or 1 day to complete the spin. Second, since the Earth keeps spinning all the time and never stops, it will give rise to the cycle of day and night. Does the Earth move around the sun, or the sun that moves around the Earth? In our previous discussion, we learned that the Earth spins on its axis. We see that the sun rises and moves across the sky every day, but the sun does not really move. It only seems that way to us. Actually, it is the Earth that is moving around, and we are moving around with the Earth. The Earth takes 24 hours to complete one full rotation. The spinning of the Earth on its axis is called rotation. Now, let us discuss more deeply about the Earth and beyond. And at the end of our discussion, you will be able to identify the center of the universe, differentiate rotation from revolution of the Earth, investigate more how the Earth moves around the sun. Look at this picture. Can you describe it to me? This picture shows us the position of the sun, the planets, and moon. The first picture might be telling us that the sun is revolving around the Earth, but that's absolutely wrong. The second picture tells you that the planets are the ones revolving around the sun. The sun is in its fixed position, the center of the universe. Since the scientists also have found out that it is actually the Earth that moves around or orbits the sun in oval path. The orbiting or revolving of the Earth around the sun is called revolution. Please set your eyes to the illustration at the center of this slide. As the Earth orbits or revolves around the sun, it will take 365 1/4 days for it to complete the revolution for the Earth to go back to its original or first position. And look at the small illustration upper left. The Earth itself is spinning on its own axis. The Earth rotates once in about 24 hours with respect to the Sun, but once every 23 hours, 56 minutes and 4 seconds with respect to other distant stars. This rotation gives us the idea of a one day. We learn from this slide that the Earth is rotating on its own axis in 24 hours while at the same time orbiting or revolving around the Sun. So there, we learned that the Earth takes 365 1/4 days or 1 year to orbit the Sun once. That is why there are 365 days in 1 year. We can see it in our calendar. So an extra day is added to February every 4 years. In that year, there are 29 days in February instead of 28 days, and the year is called a leap year. Try to check your calendar. To summarize the discussion today, we learned that the Sun is the center of the universe. The rotation of the Earth on its own axis gives us 24 hours, and that is the reason why we have the cycle of day and night. The revolution of the Earth around the Sun takes 365 1/4 days, which validates the idea of a year. It is the Earth that moves around the Sun and not the other way around. Today you are going to learn about the solar system. So at the end of this discussion, you should be able to first, describe the solar system. Second, describe the following: the stars, the Sun, the Moon, and the Earth. Third, cite some exploration of scientists on stars and solar system. What is the solar system? The solar system refers to the Sun and objects in space that move around the Sun. The Sun is the center of our solar system. It is the largest body in our solar system. 8 planets follow paths called orbits around the Sun. The shape of each orbit is called an ellipse. Other than planets, moons, asteroids, comets, meteoroids are also part of our solar system. Scientists have studied our solar system from telescope on Earth and from telescope in orbit around Earth. Examples: Galileo was the first to discover physical details about the individual bodies of the solar system. He discovered that the moon was cratered, that the sun was marked with sunspots, and that Jupiter had 4 satellites in orbit around it. Uranus was discovered by Sir William Herschel in 1781. In addition to discovering the Uranus, he also observed and catalogued over 800 double stars and 2,500 nebulae. Neptune was discovered by John Couch Adams in 1846. Adams was an English astronomer and mathematician who, at the age of 24, was the first person to predict the position of a planetary mass beyond Uranus. Astronauts have visited the moon. The spacecraft have been sent to study almost all the planets in the solar system. One of the spacecraft that has succeeded to do their mission is Apollo 11. Apollo 11 was the space flight that first landed humans on the moon. Commander Neil Armstrong and the lunar module pilot Buzz Aldrin formed the American crew that landed the Apollo lunar module Eagle on July 20, 1969. Armstrong became the first person to step onto the lunar surface. Now let us focus on the specific lessons. We will learn about the stars, sun, moon, and earth. The first fact of stars is that all stars are born in molecular clouds. Molecular clouds are cold, dark, giant condensations of dust and molecular gas which serve as stellar nurseries. Second, stars are so far away from the Earth. Even through the large telescopes, they appear only as tiny points of bright light. Third, stars seem to twinkle because we see them through the layers of the atmosphere, the gases that surround our planet. The movement of air and dust in the atmosphere bends or refracts a star's light in different directions. Because the light is scattered by the time it reaches our eyes on Earth, stars appear to twinkle. Fourth, the sun is the star that is closest to the Earth. Some stars are bigger than our sun and other stars are smaller, but they are so far away from Earth that they look like tiny points of light. The sun is a huge ball of hot glowing gases. It is much hotter than any of the 8 planets. The outermost layer of the sun that we can see is about 5,600 degrees Celsius. The sun is the most important part of our solar system. It gives us warmth and light. Without the sun, our Earth would be very cold. If there were no sun, there would be no life on Earth. The sun looks much bigger and brighter than the other stars because it is the nearest star to the Earth. At night, we can see many stars in the dark sky, but during the day, when we can see the sun shining, its light is so bright so we can see the other stars. A satellite is an object that orbits another bigger object in space. The moon orbits the Earth. It takes 27 days to orbit the Earth. That's why the moon is the Earth's satellite. It is also known as a natural satellite. The moon is our nearest neighbor in the solar system. It follows a path or orbit around Earth just as Earth follows a path around the sun. Our moon has mountains and valleys. It is covered with craters. The surface of the moon is rocky and covered with dust. The temperature on the moon can reach 130 degrees Celsius. Because there is almost no atmosphere, the temperature can drop until minus 110 degrees Celsius at night. There is no life on the moon because there is no water and no air. 12 American astronauts landed and walked on the moon between 1969 and 1972, and they didn't find living things on it. They just took pictures and collected lunar rocks and dirt. They used it to study more about the moon and found out that the surface of the moon is much older than the surface on the Earth. And the last stop, the Earth. Earth is a hard and rocky planet. There are high mountains, valleys, volcanoes, and even some craters. Earth is different in some different ways since it is covered with water. Also, the air is made of nitrogen, oxygen, and carbon dioxide. It is just right for us to breathe. Earth is home for people, plants, animals, and other living things to live because it has both water and the right kind of atmosphere. The highest temperature ever recorded on Earth is about 60 degrees Celsius, and the lowest recorded temperature is about minus 85 degrees Celsius. Do you know when the first picture of the Earth was taken? It was taken in 1968 by American astronauts when they did spacecraft traveling to our moon. Let us summarize the discussion today. The Sun, stars, moon, and Earth are parts of our solar system. The Sun is a huge ball of hot gases which gives a lot of heat and light to other objects in our solar system. Since the moon orbits the Earth, it becomes the Earth's satellite with no life there. But on Earth, people and other living things can live since it is covered by water and air. The scientists are the people who are responsible for the discovery of our solar systems. The American astronauts landed on the moon between 1969 until 1972, and in the way they traveled to our moon, they took the first full picture of our planet Earth. Before going further, let's set our goal first. So at the end of this discussion, you should be able to identify planets in our solar system and its characteristics. How many planets do we have in our solar system? Is Pluto still a planet? Can you name all the planets? The most interesting things that we should know about the solar system are planets. Now we have 8 planets in our solar system since Pluto doesn't exist anymore as a planet. Let's look at them, starting with the ones closest to the Sun, going to the furthest. The closest planet to the Sun is Mercury, then Venus, the planet that we live in, the Earth, Mars, Jupiter as the largest planet, Saturn, Uranus, and then the furthest is Neptune. As you can see, Mercury, Venus, Earth, and Mars are closer to the Sun and also smaller than Jupiter, Saturn, Uranus, and Neptune. Our planets in our solar system are divided into 2 types, inner and outer planets. First, the inner planets. The 4 inner or terrestrial planets have dense, rocky compositions, few or no moons, and no ring systems. 3 of the 4 inner planets, Venus, Earth, and Mars, have substantial atmospheres. All have impact craters and tectonic surface features such as rift valleys and volcanoes. The term inner planet should not be confused with an inferior planet, which designs those planets which are closer to the Sun than Earth, which are Mercury and Venus. Mercury is the closest planet to the Sun and the smallest planet. Because it is so close to the Sun, Mercury gets very hot. During the day, the temperature on Mercury can get as high as 430 degrees Celsius, and at night it can get very cold as minus 175 degrees Celsius. This happens because there are no clouds and very little air surrounding the planet. The atmosphere helps to keep a planet warm and when the sun is not shining. Mercury's very thin atmosphere cannot keep the planet warm at night. Mercury has no natural satellites. The surface of Mercury is hard, rocky, and covered with craters. It has a cliff and valley just as Earth does. There is also no liquid water on Mercury.
Venus is the second planet from the Sun. We can call Venus our neighbor because it is the closest planet to our Earth. Venus is the hottest planet in the solar system, even though it is farther from the Sun than Mercury. It can get as hot as 480 degrees Celsius on Venus. It is because Venus has a thick atmosphere. The air around the planet is mostly a gas called carbon dioxide. The carbon dioxide traps the heat from the Sun on the planet's surface. This is called the greenhouse effect. There are craters, mountains, volcanoes, and valleys on the surface of Venus. Venus also is a very dry planet. It is covered by thick clouds containing water, but Venus clouds contain sulfuric acid. These clouds are so thick that astronomers on Earth cannot see the surface of the planet with their telescopes. All about Earth had been discussed in the previous video. Did you still remember? Watch the video again. Mars is the fourth planet from the Sun. It is smaller than Earth and Venus. Mars can get very cold. The temperature can get as low as minus 130 degrees Celsius. In a few places, it can be a pleasant 30 degrees Celsius during the day. In most places, it never gets above freezing. Mars is a hard and rocky planet. The soil on Mars contains iron oxide or rust, which makes the ground look red. This is why Mars is often called the red planet. Sometimes the red dirt is stirred up by strong winds. These huge dust storms can last months. Mars has mountains, canyons, volcanoes, and craters. There is no liquid water on the surface of Mars now. There may be frozen water under the surface. There is ice on the surface at the coldest places. Mars has an atmosphere made almost entirely of carbon dioxide and traces of nitrogen and other gases. The second type is the outer planets. The four outer planets or gas giants, and sometimes also called as Jovian planets, collectively make up 99% of the mass known to orbit the Sun. Jupiter and Saturn's atmospheres are largely hydrogen and helium. Uranus and Neptune's atmospheres have a higher percentage of ices, such as water, ammonia, and methane. Some astronomers suggest they belong in their own category, ice giants. All four gas giants have rings, although only Saturn's ring system is easily observed from Earth. The term outer planet should not be confused with superior planet, which designs planet outside Earth's orbit. Jupiter is the fifth planet from the Sun. It is the largest planet in our solar system. All that astronomers can see when they look at Jupiter through a telescope are the tops of the clouds in its atmosphere. These clouds are made of frozen gases such as ammonia and water. These colorful clouds cover the entire planet, making it look white, brown, red, and orange. Jupiter's Great Red Spot is a storm which has been going on for over 300 years. The atmosphere is mainly made of two gases, hydrogen and helium. Deep in the atmosphere, the gases are pressed together so much that they turn into liquid. It would be impossible to land a spacecraft on Jupiter, because a spacecraft would be crushed. Jupiter is icy and rocky moons. It is surrounded by a thin ring. Jupiter also has 63 known satellites. Jupiter's four largest moons are called the Galilean moons. They were discovered by Galileo, the first person to use a telescope to look at the heavens. They are Ganymede, Callisto, Io, and Europa. These four moons are very large. Some are even larger than the smallest planets. Jupiter's moon, Ganymede, is the largest moon in our solar system. Saturn is the sixth planet from the Sun. It is famous for its extensive ring system and has similarities to Jupiter, such as its atmospheric composition. On the top of Saturn, we can see the clouds that are made of frozen gases, such as ammonia and water. But Saturn's clouds are not colorful as those covering Jupiter. Saturn's atmosphere is mainly made of two gases, hydrogen and helium. The pressure of the atmosphere is so great that a spacecraft would be crushed too. Saturn has the most spectacular rings in the solar system. These rings are made of billions of small chunks of ice and rock. Each of these pieces is like a tiny moonlet that orbits Saturn just as the big moons do. Even though these white rings stretch out far beyond Saturn's cloud tops, they are probably less than 30 meters thick. Saturn has 60 known satellites. Saturn's largest moon, Titan, is the second largest moon in the solar system.
Uranus is the seventh planet from the Sun. When astronomers look at Uranus through a telescope, they see some clouds and the atmosphere above the clouds. These clouds are made of frozen methane. Methane is a gas which we use for cooking and heating on Earth. The clouds of Uranus appear bluish-green because of the methane gas in the atmosphere above them. The atmosphere below the clouds is mainly made of hydrogen and helium. Uranus has a much colder core than the other gas giants and radiates very little heat into space. That is why it is the coldest planet in our solar system. Uranus has 27 known satellites, the largest ones being Titania, Oberon, Umbriel, Ariel, and Miranda. The moons are probably made of ice and rocks. The furthest planet from the Sun is Neptune. The temperature on Neptune above the cloud tops is minus 215 degrees Celsius. The clouds of Neptune are made of frozen methane. These clouds appear blue because of the methane in the atmosphere above the clouds. The atmosphere below the clouds is mainly made of hydrogen and helium. Neptune has a great dark spot. This is probably a storm similar to the great spot on Jupiter. It radiates more internal heat, but not as much as Jupiter or Saturn. Neptune has 13 known satellites. The largest Triton is geologically active with geysers of liquid nitrogen. Triton is the only large satellite with a retrograde orbit. Before we end our discussion today, let's summarize our lesson. Let's read it together. First, planets are categorized as inner and outer planets. Second, we have 8 planets in our solar system, which are Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. Third, all planets but Mercury and Venus have satellites. Fourth, the smallest planet is Mercury and the largest planet is Jupiter. Fifth, Jupiter and Neptune have the great dark spot. 6. Saturn has the most spectacular rings. 7. The hottest planet is Venus and the coldest planet is Uranus.
Debris, space junk. After the Sun and planets formed, there was some material left over. These small chunks didn't get close enough to a large body to be pulled in by its gravity. They now inhabit the solar system as asteroids, meteors, and comets. So at the end of this discussion, you would be able to identify asteroids, meteors, and comets and their characteristics, locate and describe the asteroid belt, identify the differences between meteors, meteoroids, and meteorites, identify what is beyond our solar system, explore the life and discoveries of scientists who explore the solar system and stars. Asteroids are very small, irregularly shaped, rocky bodies. Asteroids orbit the Sun, but they are more like giant rocks than planets. Since they are small, they do not have enough gravity to become round. They are too small to have an atmosphere. With no internal heat, they are not geologically active. An asteroid can only change due to a collision. A collision may cause the asteroid to break up. It may create craters on the asteroid's surface. An asteroid may strike a planet if it comes near enough to be pulled in by its gravity. It is one example of asteroid Ida with its tiny moon Dactyl. The asteroid's mean radius is 15.7 km. Hundreds of thousands of asteroids have been found in our solar system. They are still being discovered at a rate of about 50,000 new asteroids per month. The majority are located in between the orbits of Mars and Jupiter. This region is called the asteroid belt, as shown in the picture. There are many thousands of asteroids in the asteroid belt. Still, their total mass adds up to only about 4% of Earth's moon. Asteroids form at the same time as the rest of the solar system. Although there are many in the asteroid belt, they will never be able to form into a planet. Jupiter's gravity kept them apart. If you look at the sky on a dark night, you may see a meteor, like in the picture. A meteor forms a streak of light across the sky. People call them shooting stars because that's what they look like, but meteors are not stars at all. The light you see comes from a small piece of matter burning up as it flies through Earth's atmosphere. Before these small pieces of matter enter Earth's atmosphere, they are called meteoroids. Meteoroids are as large as boulders or as small as tiny sand grains. Larger objects are called asteroids, smaller objects are interplanetary dust. Meteoroids sometimes cluster together in long trails. There are the debris left behind by comets. When Earth passes through a comet trail, there is a meteor shower. During a meteor shower, there are many more meteors than normal for a night or two. A meteoroid is dragged towards Earth by gravity and enters the atmosphere. Friction with the atmosphere hits the object quickly, so it starts to vaporize. As it flies through the atmosphere, it leaves a trail of glowing gases. The object is now a meteor. Most meteors vaporize in the atmosphere. They never reach Earth's surface. Large meteoroids may not burn up entirely in the atmosphere. A small core may remain and hit the Earth's surface. This is called a meteorite. Meteorites provide clues about our solar system. Many were formed in the early solar system. Some are from asteroids they have split apart. A few are rocks from nearby bodies like Mars. For this to happen, an asteroid smashed into Mars and sent out debris. A bit of the debris entered Earth's atmosphere as a meteor. Comets are small icy objects that orbit the Sun. Comets have highly elliptical orbits. Their orbits carry them from close to the Sun to the solar system outer edges. When a comet gets close to the Sun, its outer layers of ice melt and evaporate. The vaporized gas and dust forms an atmosphere around the comet. This atmosphere is called a coma. Radiation and particles streaming from the Sun push some of this gas and dust into a long tail. A comet's tail always points away from the Sun, no matter which way the comet is moving. Why do you think that is? The picture shows comet Hale-Bopp, which shone brightly from several months in 1997. Gases in the coma and tail of the comet reflect light from the Sun. Comets are very hard to see except when they have comas and tails. That is why they appear only when they are nearer the Sun. They disappear again as they move back to the outer solar system. The time between one visit from a comet and the next is called the comet's period. The first comet whose period was known was Halley's Comet. Its period is 75 years. Halley's Comet last traveled through the inner solar system in 1986. The comet will appear again in 2061. We'll look up at it. Have you ever wondered what is beyond our solar system? As we discussed, the Sun is the nearest star to us. Beyond the solar system, there are billions more stars in the universe. Stars gather in large groups called galaxies. A galaxy is a collection of star systems, such as the solar system, gas and dust. The solar system belongs to a galaxy called the Milky Way. Beyond the Milky Way, there are many more galaxies and stars. There are many stars with their planets and moons beyond the solar system. Do you think there might be planets that can support life just like the Earth? How can we know all about the Earth and beyond? We can know about it since many scientists have explored the solar system and stars over the years. Although they could not reach these faraway places, they could explore them with the help of science and mathematics and tools such as telescopes. Here are a few of them. Claudius Ptolemy developed a model to predict the movements of the sun, moon, planets, and stars based on the Earth center model of the universe. Omar Khayyam calculated accurately the number of days in a year. Nicolaus Copernicus developed the sun-centered model of the solar system where the planets move around the sun in circular orbits. Galileo Galilei designed and made his own telescope. He observed sunspots on the sun, craters and mountains on the moon, 4 of Jupiter's moons, Saturn's ring, and the phases of Venus among others. Johannes Kepler developed 3 laws regarding the orbits of planets. One of them states that the planet's orbits around the sun are oval and not circular. Since ancient times, we have been observing space objects with our naked eye. However, our sense of sight is limited. With the invention of binoculars and telescopes, we are able to see much further and clearer. The 17th century astronomer Galileo Galilei first observed the moons of Jupiter and the ring of Saturn using his telescope. Today, astronomers can observe distant stars and galaxies with much more detail using large telescopes. A telescope is an optical instrument that makes distant objects appear magnified by using an arrangement of lenses or curved mirrors and lenses, or various devices used to observe distant objects by their emission, absorption, or reflection of electromagnetic radiation. Binoculars or field glasses are 2 telescopes mounted side by side and aligned to point in the same direction, allowing the viewer to use both eyes or binocular vision when viewing distant objects. The Hubble Space Telescope is a large telescope orbiting the Earth. It has helped us make many observations and discoveries about space, such as distant planets, moons, stars, and galaxies. It has also helped astronomers find out how old the universe is. The Hubble Space Telescope is known also as an artificial satellite. The first artificial satellite was launched into space in 1957 and known as Sputnik 1. During the space race of the 1950s to 1970s, the first few astronauts were successfully sent into space. In 1998, the International Space Station was launched into space to orbit the Earth. Astronauts and scientists from various countries take turns to live and work there. They use the space station as a base to carry out research and experiments on space and other sciences. So far, the furthest humans have ever been in space is the far side of the moon. The environment in space is very harsh and the other planets and moons are very far away. So scientists send space probes and rovers to explore the places we cannot reach. Space probes are unmanned spacecraft that carry instruments such as cameras, computers, and robots. Rovers are robotic vehicles that explore the surface of a planet. Rockets are used to launch artificial satellites, space probes, and humans into space. Will we be able to set up homes on the moon one day, or perhaps land on Mars or an asteroid? With imagination, intelligence, and determination, we may well become future citizens in space. Before we end our discussion today, let's summarize our lesson. First, asteroids are very small, irregularly shaped, rocky bodies. Asteroids orbit the sun, but they are more like giant rocks than planets. Second, the majority of asteroids are located in between the orbits of Mars and Jupiter. This region is called the asteroid belt. Third, a meteoroid is dragged towards Earth by gravity and enters the atmosphere. Friction with the atmosphere hits the object quickly, so it starts to vaporize. As it flies through the atmosphere, it leaves a trail of glowing gases. The object is now a meteor. Most meteors vaporize in the atmosphere. They never reach Earth's surface. Large meteoroids may not burn up entirely in the atmosphere. A small core may remain and hit the Earth's surface. This is called a meteorite. Fourth, a bit of the debris enter Earth's atmosphere as a meteor. Fifth, comets are small, icy objects that orbit the Sun. Its period is 75 years. Sixth, some of the scientists who explored the solar system are Claudius Ptolemy, Omar Khayyam, Nicolaus Copernicus, Galileo Galilei, and Johannes Kepler. 7. The Hubble Space Telescope, space probes, and rovers are tools that we can use to explore the solar system. That's all for today. Get ready and do your best during the examination.